Hello class, welcome back. Today I'm going to cover 3.3 part 1, looking at specifically aquatic ecosystems, focusing on marine today, freshwater tomorrow, and then the rest of the week we'll be doing our biome presentations through Google Slides. I am not going to give an assignment for this section because I really hope that you guys are working really hard on your biome projects, or if you need more time, please get it done. Remember that the para and I, we can check. We can check your progress, and we will. So please stay on top of your project that you will be presenting later on this week. But today I'm going to talk about biomes and how they are defined, and then talk about aquatic ecosystems and how they are defined, but then really just today focus on marine ecosystems, and tomorrow will be a shorter lecture dealing with freshwater ecosystems. So biomes are just different regional climate communities, and a lot of times we describe them by their abiotic and biotic factors. Your book has these graphs, and I hope you are putting them in your PowerPoint presentation or finding similar graphs on the internet. But really it's breaking it down due to its average temperature, the month, and then average precipitation. So the blue bars are showing the average precipitation in millimeters, okay, and the average temperature is this red line. So over here is the grid or axes for measuring precipitation during a certain month, and over here is the average temperature. So don't get that mixed up. These bars do not correlate to this. They color coded it. Average temperature is red, precipitation is blue. Now, Earth has several biomes, and your book actually gives 10. This one only shows 7. So remember, you need to find a diagram for your biome project that shows you where your biomes are located worldwide. But here you can kind of see we're kind of in the grassland, temperate, deciduous forest region. Okay, moving on to aquatic ecosystems. So a lot of factors affect aquatic ecosystems, specifically water depth, and you'll see that when I discuss marine ecosystems. Temperature can be a huge factor. Sometimes there are cold ocean currents that develop kelp forests, whereas with warm ocean currents, and depending on its location and latitude, you get coral reefs. Currents themselves, salinity, how salty it is, the flow rates, is there a lot of current moving through it? Is it fast moving or is it very slow, where a lot of debris kind of hangs around and the water looks really murky. And then murky is what I meant to say, not mercury. And then nutrient availability. Is there a lot of producers present? Is there a good food source? Does it have, let's just talk about oxygen levels. So like right now off the coast of Louisiana, when the Mississippi flows into the Gulf of Mexico, there are some parts that do not have a lot of oxygen due to maybe some type of algae bloom. Okay, so all of those factors affect it. But marine ecosystems, we can classify them based on their distance from shore as well as how deep they are. So I'm going to start with distance and then talk about depth. So distance from shore, the first zone is called the intertidal zone. Basically, it's your high tide and low tide. Okay, it's the area of land that's covered during a high tide and exposed to the air during that low tide. And so the organisms that are found in the intertidal zone go through regular extreme changes on a daily basis because you get 2 high tides and 2 low tides. And so starfish, in the intertidal zone, if they get left out in a dry area during that low tide and they don't, find water, they could desiccate, they could dry out and die. Okay, the coastal region is the next layer, and it's the low tide mark to the outer edge of the continental shelf. So if this is my low tide mark, and here's the outer edge of the continental shelf before it drops off. And so we find here in the coastal ocean abundant sunlight and nutrients, and as a result, life is very abundant because now you have plants and there's lots of nutrients for those organisms to thrive on. Beyond the coastal ocean, you get the open ocean. It's the edge of the continental shelf and beyond. 90% of our oceans are open ocean. So, yeah. Okay, so the second way you can classify marine ecosystems is by their depth. And this diagram pretty much simplifies it. There's 2 zones, a photic zone and an aphotic zone. And so the photic zone means where light can penetrate through, and photosynthesis is present. So you might see some kelp forests, okay, You tend to see a lot of organisms in this area. But then as you go past the aphotic zone, as you go deeper in, in depth in the ocean, it gets darker and pressure increases and there's no photosynthesis. And so you get a different diversity of organisms that live, entirely different from the organisms from up here. We do find life on the bottom of the ocean floor, especially near hydrothermal vents. They don't do photosynthesis. They do another process that's similar to photosynthesis, but instead of using light, they use organic chemicals or inorganic chemicals to make their sugars, and other organisms thrive off of this. So. Okay, that does it for marine ecosystems. Remember, please, please, please work on your biome project and complete the exit card. Thank you.